Hi, my name is Drew. I am a tutor here on Wyzant. I tutor a number of subjects, but today we're going to be looking at some sequences. So the person that posted this question here. We're given that A1 in this sequence is equal to 3, and then we're given this recursive equation, A of n plus 1 equals 3 over A n plus 3. Now, there was some kind of ambiguity in how this was written. It was written kind of in one line of text, and it was unclear whether this expression here was meant to be this that I wrote or 3 over this whole thing plus 3. I went with this one here because it seemed like that probably was the right one. In any case, we're just going to assume that that is it. But the principles that we're going to go over apply no matter what, depending on what the problem is. So this type of question is testing your base understanding of what a recursively defined sequence is and how to find indexed values within that sequence. So in this case, what I'll be doing, instead of just like going through, here's the answer, I'll be explaining what's being asked here. So in this case here, they're saying that the first number, so this is index is 1, this is the first number, A1. The first number is 3. And then every number after that, what happens is you take 3 and you divide it by, so this is A of n plus 1, right? So we're considering A of n plus 1. So say this is n, and we want to consider the next one, which is n plus 1. So we're considering this number. So this number, n plus 1, you take 3, you divide by the an, which is the previous number, and then you add 3. So in this case, and this is the case for every single one. So once we have n plus 1 here, then if we want to find n plus 2, then we would use n plus 1 on this as this value here, and that would be n plus 2, and so on. This is the whole idea of recursively defined functions. It takes some previous values and uses that to find future values. So in this case, our first one, and let's say, so this is n equals 1 for 3. So if we want to find the second one, which is this one here, then we would take 3, divide it by the previous one. So the previous one would be 1, so we divide that, and then we would add 3. So in this case, 3 divided by 3 is 1, we add 3, and then we get 4. So that would be A2. And this the similar thing for A3. So if we were trying to find A3, if 3 is n plus 1, then an is A2, right? 3 divided by A2 plus 3. And we do the exact same thing, 3 divided by A2. Now A2 is 4, so we do 3 divided by 4, and we add 3. And so you can add this together, doing, I think it's 15 over 4, if I'm not mistaken. But let me show you. Yeah, I think that's right. And that would be A3. And you do the same thing for A4. So this time, instead of using A2 and A3, where you're looking for A4, it would be 3 divided by A3 this time, plus 3, and you get the idea. And this one is just plugging things in its basic arithmetic there. So that gives you an idea of how recursively defined sequences work and what they actually are, and it gives you the tools that you need in order to be able to find these values.